had a good Monday, Tuesday. The meaning of time has lost some value at this point, but if you're following along at the pace that we would be if you were in school, today would be Wednesday, March 18th, and we would be starting notes for 8.5. So, if you're ahead, that's fine. If you're behind, be careful. Don't want to make that a trend, but we are now going to move on to notes for 8.5. So if everyone can take out their rational expressions applications sheet that I gave you last week, that is what we will be working through today. And then you will have a homework that expects you to be able to do the same thing. So there is nothing new about this conceptually. It's just now merging it with what you have already learned last year in geometry. So if you'll look kind of through this really quick, I'm expecting you to know the area of rectangles and squares. I'm expecting you to know the area of triangles, volumes of prisms, areas of trapezoids. And that's about as complicated as it'll be as far as geometry. What we're doing, instead of having lengths and widths in nice whole numbers or even numbers that you would think about, we're doing areas, lengths, widths, volumes, heights, all the dimensions as rational expressions. The reason why is because what we're doing is working with rational expressions, and this is a way to do that. So let us do number 1. Number 1 says find an expression to represent the area of the rectangle. So if we have a rectangle, we know that area equals length times width. At least I hope that we know that. Here, I give you a length and a width, so we just need to multiply those two rational expressions together. So you have a 2x over x squared minus 12x plus 27 times x squared minus 81 all over a 4x cubed plus 36x squared. So this is our length times our width. We simply just need to simplify these rational expressions. So I usually will go like here to here to here to here. So working with the top left, that is already as simplified as it can be. The bottom left looks like it can be factored to a -9 and a -3. Our top right is a difference of perfect squares. And our bottom right, I can pull out a 4x squared. And if I do that, I'm left with x plus 9. Once it's simplified and factored out as much as you can, you're allowed to start canceling. All the terms are multiplied together, which means that it is allowed to cancel. This 2x will cancel with this, and you get a 2x left. So across the top, everything canceled out, and I'm left with a 1. Across the bottom, I have a 2x times the quantity x minus 3. Bingo. The one underneath that, number 2, is the exact same problem. You just have a different set of expressions to rationalize. So if you do area is equal to a length times a width, and you would say, okay, I have x squared plus 3x minus 10 all over 7x minus 14 times 3x squared minus 11x minus 20 all over 25 minus x squared. I'll work in the same order. So if I factor this one, I get an x minus plus 5 and an x minus 2 all over, I can take out the 7 and I'm left with an x minus 2 times, one of these will be a 3x and the other will be just an x. So factors of 20, we can get to a negative 11, so maybe a minus 4 and a plus 3. 3x, that's a negative 12x, but plus 3, ooh, no, that's negative 9. That doesn't work. 3x, so times, 5. 5 and 4. So if we do 3x minus 5 and plus 4, there we go. 4 times negative 5 is negative 20. 3x times negative 5 is negative 15x, plus 4x, negative 11x. This one is an almost difference of perfect squares, but please remember that your variable term needs to be positive, your constant term needs to be negative. So I'm going to turn this into a negative 1. That will make this a positive x squared term minus 25. And now I can say that that is a negative 1, x plus 5, x minus 5. Okay, I'm going to start canceling out. This x minus 2 and this x minus 2 go away. X plus 5 go away. X minus 5 go away. So on the top, I am left with a 3x plus 4. And on the bottom, I am left with a negative 7. Don't forget this poor little negative 1 here. Yeah. Jolly good. Okay, number 3. Number 3 says if the area is, and then it gives you an expression, and the length, and it gives you an expression, find an expression to represent the width. Okay, so if we know area is a length times width, and we're given area, and we're given length, and we're trying to solve for width, what we need to is solve for width in this expression. So to solve for W, I would have to divide by 1 over length, 1 over length, and you get that width is equal to area divided by length. So now this is the same thing, except for now we're dividing rational expressions. So I get that width is equal to area, which is a squared over b minus b, all over the length, which is a over b plus 1. To be able to divide rational expressions, you have to get a single rational expression on top and a single rational expression on bottom, which means that I need to turn these into the same rational expression as this. So if this is a b over 1, and this is a 1 over 1, the denominator here is b, which means that I need to multiply this term by a b over b to get that common denominator. Exact same thing here. This is a 1, but it needs to be a b, so I'll multiply by a b over b. So on the top, I get my common denominator of b, and I get a squared minus b squared as the numerator. On the bottom, I also have a common denominator of b, and I get a plus b as the numerator. Now that these are single rational expressions, I'm allowed to take this and multiply by the reciprocal, so that this will cancel out, and then I'll multiply by the reciprocal here. So times b over a plus b. That cancels out. So if I'm working with just this and this now, we can do the difference of perfect squares here. So we end up with an a plus b times an A minus B all over B times a B over A plus B. This A plus B and this A plus B will cancel out. This B and this B will cancel out. And I am left with A minus B as my answer. Okay, number 4. This is our use of triangles. We know that the area of a triangle is 1/2 base times height. So if you look at your sheet there, what you'll have to do to figure out area is say, okay, it's 1/2 times, and then the base I give you is x cubed plus 11x squared minus 26x all over 3x. So that's 1/2 times base and then times height, which I give you as 9x plus 18 over 6x cubed minus 24x. Not that bad, right? Just gotta simplify these expressions like we've been doing. So, if I simplify this one here, I'll take out an x, and then I'll be left with x squared plus 11x minus 26 all over, I'm going to multiply this 1/2 in, because 1 times all of this is 1. 2 times 3x is 6x. Times, and here I'm going to take out a 9, and I'm left with x plus 2. And on the bottom, I'm going to take out a 6x, and I'm left with x squared minus 4. Okay, if I factor this one more time, I get x times x plus 13, x minus 2, all over 6x times a 9x plus 2 all over 6x. This is a difference of perfect squares, so it'll be an x plus 2, x minus 2. Great. Let's cancel out. So this x plus 2 and this x plus 2 cancel out. This x minus 2 and this x minus 2 cancel out. This x and this x cancel out. Now let's do, I'm going to come up here. On the top it looks like I'm left with a 9 times x plus 13. And on bottom I'm left with a 36x. So I can reduce this, I guess, one more time. 9 and 36 both are divisible by 3. So I get 3 times the quantity. Oh, they're both divisible by 9. So let's do that, because that seems way more efficient. If I divide both by 9, I get x plus 13 over 36 divided by 9 is 4x. Nice. I feel like without any questions, I go through these so quick. Please realize if I'm going too quickly, you have the power to pause me and rewind me. You can watch this lecture over and over again for pure entertainment value. So many possibilities. Okay, let's move on to number 5. Find an expression to represent the volume of the rectangular prism. So volume is not very much more difficult than area, except for it's length times width times height. So, if we look at number 5, we know that volume is equal to length times width times height. And I've given you a length times width times height there. Let us go ahead and start simplifying these expressions. So I have a 5x squared minus 32x plus 12 all over 10x cubed times 18x squared all over 45x squared minus 18x times x squared plus 14x plus 48 all over 36 minus x squared. Okay. This first one, factors of 12 that will add up to be a negative 32. Let's go with a negative 2 and a negative 6. Negative 2 times negative 6 equals a positive 12. 5x times negative 6 is negative 30. And then minus another 2x gives me a negative 32x total. Over 10x cubed. That can stay as it is. Okay, we have 18x squared over, let's pull out a 9, and we're left with a 9x. We're left with a 5x minus 2. Here, factors of 48 that will add up to 14. 6 and 8. This is another difference of perfect squares, but be careful, it's flipped, where you have to pull out your negative 1. So I'm going to pull out the negative 1, and then I get an x plus 6, x minus 6. Yeah! 5x minus 2's cancel out. X minus 6 cancels out. X plus 6 cancels out. This 9x will turn this into a 2x. This 2x will cancel out with this and turn it into a 5x squared. I think that's all I can do. So if I run my eye across the top, everything canceled out except for the x plus 8. And then on the bottom, I have a 5x squared, and then this negative 1. So negative 5x squared. Woo, woo, woo. Okay, for number 6, I'm asking you how to find the volume, find the height if you're given the volume. So for 6, we know that volume is equal length times width times height. And I'm asking you to find height. You need to divide both sides by an L and W to solve for H. So we get that height is equal to volume divided by length times width. Okay, so the volume is equal to 12x plus 16 divided by our length, which is a 9x squared minus 16 all over an x squared plus 2x minus 35 times my width, which is 8x squared minus 40x all over 3x minus 4. Okay, let's simplify and reduce the denominator as much as we can before we flip it up. So if I look at this top one, this is a difference of perfect squares, right? We have a 3x and then we have a 4. So looking at just this bottom for now, I'm going to come back and plug it back into this. I get a 3x plus 4 times a 3x minus 4 all over factoring this expression, I get an x plus 7 and an x minus 5 times. I'm going to pull out an 8x, and I'm left with x minus 5 all over a 3x minus 4. This will cancel out. This will cancel out. And it looks like for this denominator part, I am left with 8x times a 3x plus 4 all over 7, or x plus 7. So now I can take this 12x plus 16, turn that into 12x plus 16 over 1. Right, because anything divided by 1 doesn't change it. And then now I have this single rational expression as a fraction, so this is now a complex fraction. So to get rid of it in the denominator, because that's what this is, I need to multiply by the reciprocal. So I'm going to multiply this by x plus 7 all over 8x 3x plus 4. This is already reduced as much as possible, so I just have to reduce this 12x plus 16, and I can pull out a 4. So if I pull out the 4, I get a 3x plus 4 all over 1 times x plus 7 all over 8x times 3x plus 4. These cancel out. This 4 cancels out, and this becomes a 2x. So my answer becomes x plus 7 all over 2x. Let's double check. Lost my paper. Oh, never mind. Yes, we are correct. Good job, team. Okay, 4 more problems. Let's do some perimeter problems. Remember, perimeter is the length of the entire way around something. So, number 7. Perimeter, right, would be the length of this, plus the length of this, plus the length of this, plus the length of this. Or, another way to say that is that perimeter equals 2 times the length plus 2 times the width. So you can see why I threw perimeter problems in here is because now we're going to be adding rational expressions. So here, when we're multiplying, it doesn't matter about common denominators, but I had to throw in some perimeter problems so that we did have to worry about common denominators. So if I'm asking you to find the perimeter there, I have given you the length and the width. So we need to add those together and then multiply by 2, right? We can say that this is the same thing as 2 times length plus width. Okay, so we get that perimeter equals 2 times the length, which is x squared minus 4x all over, oh, that's the next problem. Sorry. Get the 15 over x plus 5 plus x squared plus 8x all over x plus 5. Now, I've been pretty nice to you here because these already have a common denominator, so all you have to do is combine the numerators. So we get this is equal to 2 times x squared plus 8x plus 15 all over x plus 5. Now if we factor out the numerator, we would get that perimeter is equal to 2 times x plus 3, x plus 5 all over x plus 5. So these x plus 5s cancel out, and you're left with 2 times this quantity, 2 times the quantity, x plus 3. the next perimeter problem, it's the same thing except for I have not given you a common denominator. So you have to find that first. The equation is still the same though. Perimeter is equal to 2 times the length plus width. So we get 2 times, then my length is x squared minus 4x all over x squared minus 5x plus 4 plus 6 over x minus 1. So I'm going to factor this out so I can see what this denominator is missing. I'm just going to factor out the whole thing actually. So on the top I get an x plus 2, x minus 2 all over an x minus 1 and an x minus 4 plus 6 over x minus 1. So now that I've factored it out, I can see what's missing from this denominator that this one has, and that's this term, right? So I'm going to multiply both the top and the bottom of this expression by an x minus 4. So if I say x minus 4 over x minus 4, I now have 2 times the quantity, x plus 2, x minus 2. My denominator is now the same, so I'm just going to put that in the middle. X minus 1, x plus 4, oops, minus 4. Okay, and then I can add plus a 6x. Now, you might be tempted at this point to start canceling things out like this x minus 4 and this x minus 4. Please recognize that because there's addition, we cannot do that. You can if there's addition or subtraction within a protected expression, and this was multiplied by this, which was multiplied by all of this. This is multiplied, multiplied, added, and that messes us up. So I'm actually going to backtrack and turn this back into what its unfactored form was and combine all the like terms. So that leaves me with 2 times the quantity, and then it's an x squared minus 4x, and then plus 6x minus 6 times negative 4, 24, all over x minus 1, x minus 4. Combining these like terms, this becomes a 2x. So now I'm looking to factor x squared plus 2x minus 24. That will be x minus or plus 6 and an x minus 4 all over x minus 1, x minus 4. So now I can cross these out and I am left with 2 times x plus 6 all over x minus 1. Okay, 2 more problems, y'all. So for trapezoids, area of a trapezoid, you could look this up, but you should have learned it in geometry. The area of a trapezoid is 1/2. It's kind of like a triangle, but it's a triangle as well as a square. So we have base 1 plus base 2 times height. This is my favorite type of problem because I'm going to have you multiplying rational expressions as well as adding rational expressions. Yes. double whammy. So, if you start doing this problem, you would say that area is equal to 1/2, and then what are the bases? So it is important to understand what a trapezoid is, right? If you have a trapezoid, this is a base, because it's on the bottom. This is a base. The height is this. I think you have a homework problem where I give you a trapezoid that doesn't have two angled sides. It's like this. This is no different. This is still the base, this is still the base, and this is still the height. Okay, so don't let that fool you when you get to this homework problem. That's still a trapezoid. Okay, so if I look at my problem, I get that base 1 is x plus 9 over 2x, and then plus x plus 3 over x times height, which is a 12x over x squared minus 2x minus 35. According to order of operations, I have to do what's in parentheses first. And then I cannot add these expressions because they don't have a common denominator. Luckily, it's very simple to make this one have a common denominator. I just need to multiply this term by a 2 over 2, right? So I get that area is equal to 1/2 times x plus 9 all over 2x. This becomes 2x, so I can just say plus, make sure you distribute this 2 to both terms, 2x plus 6. Times a 12x, and let's go ahead and factor this bottom. We get an x minus 7 and an x plus 5. Area equals 1/2. Combining like terms up here, I get a 3x plus 15 all over 2x times 12x over x minus 7, x plus 5. Woo! Area equals 1/2 times, I'm going to factor out a 3 here, so we get 3x plus 5 all over 2x times 12x over x minus 7, x plus 5. Now because everything in here is all being multiplied together, I can start canceling. So this x plus 5 and this x plus 5 will cancel out. This 2x will make this a 6. This 2 will make this 6 a 3. So if I go on top, I have 1 times 3 is 9 over x minus 7. Okay, last problem, y'all. For problem 10, it says, write an expression to represent the surface area of the rectangular prism. So surface area is the area of every single surface. So of a prism, you have 6 different surfaces, right? So if I have this prism, please bear with me. Okay. If I have this prism, to find the area of this face right here, I would do this length, sorry, that's going to be a height. I would do this height times this length. That would get me the area of this, right? Then I have to realize that there's an exact same area but on the other side of the cube. If I wanted the area of this, this is a width times a height, so that would give me this. But then I have to remember that there's another one on this side. And then finally, if I wanted the area of this, that's the length times width. I would do that, but then I have to add another one because there's one on the bottom. So the equation for surface area, prism, is 2 times length times width plus 2 times length times height plus 2 times width times height. Because that is the area of every single face, and then realizing that there's an exact same area but on the other side of the cube. So I would say, okay, surface area is equal to 2, my length times my width, so that is a 6x times x over 4 plus a 2 times a 6x times the height, which is a 3 over 2x, plus a 2 times the x over 4 times 3 over 2x. Okay, so let's deal with our multiplication within each parentheses first. So surface area is equal to 2. These x's cancel out. The 4 and the 6 reduce, right? This reduces to a 2, this reduces to a 3. So I get 2 times a 3 over 2. Nice. In this case, the 2 will reduce with this 6, and I'm left with plus 2 times a 9 over x squared. Less ideal. In this case, the x's cancel out, and I'm left with a plus 2 times a 3 over 8. So if I put the 2's all in, 2's here cancel out, and I'm left with a 3 over 1 plus 18 over x squared plus 3 over 4. Before I can add all these expressions, I have to have a common denominator. It looks like this one is missing a 4 and an x squared, so I'm going to multiply a 3 over 1 by the 4x squared over 4x squared. This one's just missing a 4, so I'll multiply that one by a 4 over 4. And this one's missing an x squared, so I'll multiply that by an x squared over x squared. So all my denominators are now 4x squared, 4x squared, 4x squared, which is what I want. Here, I end up with a 12x squared. Oh, darn. 18 times 4. 72 plus 72 plus 3x squared. Okay, so if I combine like terms, I get a 15x squared plus 72 all over 4x squared. Looks like I can factor out a 3. Don't know if that'll help us, but we might as well check. I get a 5x squared plus 24. I don't think we can reduce that any further. Okay, there y'all have it. That is your lecture for 8.5 homework, applications of rational expressions. This is homework. I realize, I guess all of this is homework because you're at home. So please work on that. We will have a quiz. What is today supposed to be? Wednesday. So I think we're reviewing then 8.1 through 8.5, and then you'll take that quiz on Friday. Please realize that you have to scan 8.3 homework, 8.4 homework, 8.5 homework, and the quiz, all completed front and back using the instructions on Google Classroom all at once by 3:30 on Friday. They have to be one single scan. I posted the instructions on how to do that in Google Classroom. So as you get these done throughout the week, just set them aside. Please don't lose them. Friday before 3:30, make sure that you can do that you understand how to scan, either with a printer or by one of the links to the apps that I posted on Google Classroom, because I will not accept I couldn't figure out how to scan as an excuse for late homework. Okay? So 3:30 Friday, 8.3, 8.4, 8.5, and the quiz, all scanned as a single attachment. Google Classroom will not let you upload more than one. So it has to be a single attachment, including all of those. Please try as hard as you can on the quiz. Remember that the worst grade that I'm going to be giving you is a 9 out of 10, because I just want to see what you know and what you don't know so that I know what to review before we get back to school and have a test on it. So, good luck with this week. If you have questions, please be posting in the comments to the video or on Google Classroom or emailing me. Friends, if you see that someone has a question and I haven't responded, feel free to help them out if you know what the answer is. That's the best form of collaboration we can get in the age of coronavirus. So, there y'all have it. That's it for lectures this week. Y'all have a good one. Bye.